Okay, so basically what is going to happen today is I'm going to take a piece of liver and a piece of potato and put it in some hydrogen peroxide. So do you guys have any guesses of what will happen when I do this? Maybe? Anyone?
Is it gonna make bubbles?
You're correct. Why do you think it's going to make bubbles?
Oxidation. Sort of.
Yeah, you're pretty much on the ball there. So basically, let's see. Let's just write down. Okay, so hydrogen peroxide is H2O2. So you guys think it'll make bubbles, right? So basically what's going to happen is, and then there's definitely going to be O2. Is what you're guessing, because oxygen, O2 gas. So O2. And then for hydrogen, what do you think will happen? Like, what do you think the end products of this whole reaction will be? Given the...
Is it gonna become hydrogen gas?
No, it's not going to become hydrogen gas. It's actually going to become water. Because that's like the general decomposition of hydrogen peroxide is, like, it'll naturally become oxygen and water if you just leave it out. This is a really slow process though. So basically, do you guys know what hydrogen peroxide like does to living cells though? Like, what is it to living cells?
But you use to clean wounds.
Yeah, it is used in a topical solution as kind of just like clean wounds, disinfectant. But actually, in like concentrations to like at the cellular level, it's actually a poison. So important to know: do not drink this stuff. So yeah, basically what's going to happen is that I'm going to put these into the hydrogen peroxide. And an enzyme in the liver and the potato called catalase will react to the hydrogen peroxide. So what sort of reaction do you guys think this is? From like hydrogen to oxygen and water. So like
Decomposition.
it is a decomposition if you don't, have any like reactant, like we're adding an enzyme and an enzyme is a catalyst. Do you guys know what a catalyst is? Anyone? No? So a catalyst is basically, in our sense, a protein catalyst that will speed up a reaction. So basically, it's going to speed up this reaction from H2O2 to oxygen gas. Let's do a little chemistry here. And liquid. Also liquid. So yeah, basically what's going to happen is the catalyst is going to speed up this whole process, and it'll be a reaction. So what do you guys think this reaction will look like? It'll be bubbling, so let's just get on with it. Do you guys think one will react differently to the other? Like the potato compared to the liver?
Yes.
Yes. Why do you think one will react differently than the other?
Because the liver will be mostly made up of proteins and the potato will be mostly made up of starches.
That is true, but let's just see how that turns out. So this is a potato. I'm gonna drop that in there. So, let everyone take a look at that. Oh, there you go, camera. You guys see what's happening there?
It's bubbling.
Yeah, it is. Woohoo, bubbles. Okay, cool. And now we'll do the liver that I grossly chopped up this morning. Okay. You ready? What? Oh, just kidding. Whoops. So, you see what's happening?
More bubbles.
Yeah.
Lots of bubbles.
So Cam was right. It's definitely making way more bubbles. Hopefully it does not go over to the top. And
You
then
just suck it off and it goes on top.
we'll just, there we go. Just some nice liver bubbles, right guys? As I pass it around, because if you guys feel near, maybe not. I'll let this settle first. But if you guys feel this, it's actually a little bit hot now. So what kind of reaction would that be, like in terms of like chemistry? Exactly, it is an exothermic reaction. So basically it's releasing heat, so then we can add onto this that basically it's releasing heat. Energy. I'm not a chemist. Energy. Your chem teachers can teach more. Okay, so basically we went over that you think that there's a lot of proteins in the liver which cause this kind of reaction to happen as opposed to the really starchy potato. But what I want you to know is like, what do you think, what is the liver in the body? Like, what does it do for you?
Detoxify stuff.
Exactly. And what is hydrogen peroxide?
Toxic.
Exactly. So the liver is actually reacting this aggressively because that is where most of the enzyme catalase is located. I actually am not sure if this is where the liver is in the body. I'll get back to you on that, kids. So yeah, what part of this reaction, like what part of the enzyme do you think is being affected the most by the substrate catalase? If you were you were paying attention in class earlier, the active site is what's being affected the most. So yeah. And like, why is that? It's because peroxide is the substrate for catalase C enzyme. Da-da. Yeah, so basically we already know what this like reaction would produce, right? Oxygen and water. So what would be a good way to test that like maybe the reaction has gone through? Given that I have a lighter and some wooden splints here.
Could you burn off the oxygen produced?
Exactly. So what do you think will happen when if I light this and stick it in this very messy tube?
The bubbles will burn?
Well, hopefully the bubbles will pop. Hopefully the bubbles will burn. But there we go. See, look, it reignited, which is obviously a sign of what in the test tube.
Oxygen?
Exactly. Let's hope Eka does not burn down now. Oh my. Da-da-da. Safety. Yeah, so why do you think I use hydrogen peroxide rather than just because it's a substrate for catalase? Like in regards to like the whole body function. So like why do you think I use hydrogen peroxide as the water, or not as a liquid? No? Well, it's because hydrogen peroxide is actually produced in the body naturally because of metabolic processes. It's a byproduct. So your body doesn't want to make it, but because of like the oxidation in like the whole cycles of the body and the metabolic process, it's produced, which creates hydrogen peroxide. And you want to see like, this is how your body deals with that kind of toxicity. So basically what I want you guys to think about now is like, how do you think we could affect the reaction speed of this experiment?
More or less catalase?
Yeah, that's one. So that would be substrate concentration. What other things would affect enzymes or like catalysts?
Temperature affected?
Yeah, temperature is definitely one of them. And then we got one more. It's a little more chemistry related. Big colors, changing colors, paper.
Is it going to be surface area?
Nope.
The pH?
Surface area can also affect it, yes. But
The pH?
yeah, pH, acidity of the whole shebang. So yeah, do you guys have any like hypotheses of like what you think the optimum maybe conditions would be for like this reaction to take place, like liver working on hydrogen peroxide?
Your body temperature?
Yeah, body temperature. What about like acidity? Like
Slightly acidic. Is that your body's slightly acidic?
that's true, but liver is actually completely neutral. Yeah, it's like a pH of around 7, and catalase actually. I probably shouldn't tell you this, but works best at like 6.99 pH, very close to neutral. So yeah, how do you think we could measure this reaction if we wanted to measure like how quickly it's going on, how much?
Could you measure the pressure increase as oxygen is produced?
You could, but we don't have the equipment for that. But I like the thought. Anyone else? Any other?
Could you have some sort of covering on the top and have one of those things, like a probe that reads the oxygen level?
Yeah, you could do that. That would be cool. Again, we're a high school, so we don't have that kind of like equipment, but I like it. You can bring this off to university. You can like. Anyone else?
Can you put balloon on top and trap that oxygen?
Yeah, you could. It would have to be a really, really sensitive balloon in that case. But basically, I just want you guys to think about this because we'll be doing a lab with this coming up now.